4.2, graph quadratic functions. In vertex or intercept form. So we did standard form last week. We're on to vertex and intercept form this week, or for this section. So just as a reminder, vertex form is y is equal to a times x minus h squared plus k. And the vertex is at hk. So you change the sign on the h, same sign on the k for the purpose of doing it. And your axis of symmetry is still at, x equals h, whatever that value is. Intercept form is in the form y is equal to a times x minus p times x minus q, where the intercepts occur at p and q, and the axis of symmetry is halfway between those values. So the axis of symmetry is at x equals p plus q divided by 2, so whatever those values are. And then your vertex would be at whatever that point is, and then plug it in and get the y value. So we've got graph the function, label the vertex and axis of symmetry. So same instructions as the last section, and that's how it's going to look on your quiz and test. Basically, it's going to all have basically graph the function, label the vertex and axis of symmetry. It's just a matter of which form you're doing it in. So number 6, we've got y is equal to 3 times x minus 7 squared minus 1. So my vertex for this one is at, HK, so it's opposite sign on one inside, same sign on the one outside. So this is going to be at 7, negative 1. My axis of symmetry is at x is equal to 7. And we're still looking at if there's a negative sign, or basically if it's positive out front, to know if it opens up or down. So what does this one do? Up. So I don't think that's straight. There we go. Okay. So graphing the same way. So my axis of symmetry is at x equals 7. So I've got my dotted line there for that. My vertex is at 7, negative 1. So it's down here. Now, this is where, when you're finding the other points to actually be able to graph your parabola, I probably wouldn't go use 0 for this one, because when I plug in 0, I get some really exorbitant number that I can't graph. So this is where I would pull something like either 6 or 8, and obviously it's a harder number to plug in, but it's something reasonable to graph. So if I plug in 6, then I would get 3 times 6 minus 7 squared minus 1. So that's negative 1 squared, which is just 1 times 3 is 3, minus 1 is 2. So then at 6, I would be up here at 2. That's 1 away in this direction, so 1 away in this direction. I also have a point there. Oops, not that. And there's my parabola. You look confused.
I don't know if I'm just dumb.
Wait, so if it's 2, you just move 1 away from each side. So if it was 4, you move 2 away from each side.
No. I used 6, which is 1 away from that. And I plugged it in over here, and I got 2, which was up here.
Oh, okay.
Do you always find a number that's 1 away?
How did you get
I don't necessarily always do that. Sometimes I'll use something that's like 2 or 3 away. In this case, it just made the numbers easier, so that's why I did it. But, like, when 0 is an option, I like to plug in 0, because usually, like, in the last section, most of the time it made everything cancel nicely. But this one, if you used it, that's 7 away from your axis of symmetry. And if I plugged in 0, then I would have had -7 squared, which was 49, times 3, which is some really big number minus 1. That would have been, like, way off my graph, so that's not even reasonable. So you can, but it's not reasonable. So I usually just pull one that's within 1 or 2. Yes.
How'd you get 2? I just dumb.
Because, like, at the...
6 minus 7 is -1,
Oh,
squared is 1,
negative.
times 3 is 3, minus 1 is 2. Yes.
For the vertex, how did the 7 become positive?
So it's always the opposite sign in here. Same sign out here.
Oh, okay. I didn't know it was opposite sign.
Yeah. So x minus h, opposite sign here, plus k, same sign here for that one.
So if it was a positive 7 and 3x plus 7, it would be minus.
Yeah, so if it was 3 times x plus 7, then this would have been a -7. Yep, but outside will always be the same. That's the easy one to remember. The inside one's hard. Let's see. 8. Y is equal to 2 times x plus 1 squared minus 3. Vertex, so yep, opposite sign inside, so -1, outside same sign, -3. So what does that make my axis of symmetry? X equals -1. And then, are we opening up or down? Up, to positive. Yeah, number out front. It's always what we're looking for. All right, so axis of symmetry at -1. Vertex at -1, -3. So now with this one, I would probably use 0. It happens to only be 1 away, and obviously 0 is a lot easier to work with than other things. So if I plug in 0, I would have 2 times 0 plus 1 squared minus 3. And so that's 1 squared is just 1, times 2 is 2, minus 3 is -1. So that means that at 0, I have a point there. It's 1 away on this side, so also 1 away on this side, I have a point. Cannot connect the dots today, apparently. And you have your parabola. All right, I'm going to backtrack slightly because I want you to see something. Number 4, they gave a interesting scenario where they had y is equal to x plus 4 squared. So I'm not actually going to graph this one necessarily, but just for the sake of time. But what is the vertex of this one? Yep, -4, 0. Because out here there's nothing, but you can imagine there's a plus 0 to get that. So then your axis of symmetry would be at x equals -4. And so then if you graphed it, obviously you would just, you know, pick a number on either side and plug it in, and then you'd be ready to go. But that's the main thing I wanted you to see is it's not written, so it's got to be 0.
It'd be imaginary one in front.
Huh?
It'd be imaginary one in front too.
Yeah. And if it was just like, say, x squared minus 2, like if it looked like this, okay, this is the k values. This is your y value of your vertex because it's not in parentheses being squared. That's the difference here in these two. Is if there's something in here being squared, then we have that. But this would have a vertex at 0, -2, and an axis of symmetry at x equals 0, if that was the case right there.
So,
I don't think there's any in the book like that, but I just want you to be aware. Because this looks more like the ones we had the other day in the other section, but that's the quick way of how to get there. All right. Okay on vertex form. Okay. Graph the function, label the vertex, axis of symmetry, and the x-intercepts. So the ones that are in intercept form also need the intercepts labeled. So number 14, we've got y is equal to x plus 1 times x minus 3. So basically, if we set this equal to 0 and we solved, okay, we would have x plus 1 equals 0 and x minus 3 equals 0, and we solve for x. Then those values are your intercepts. So we're always going to change the signs on the intercepts. Okay, the intercepts are going to have opposite signs. So my x-intercepts are going to be at -1 and +3. For the vertex, I take those two numbers and I add them together and divide by 2 to get the x-coordinate of the vertex. So for the vertex, I've got -1 plus 3 divided by 2, which is equal to 2 over 2, so that's 1. So that's my x-coordinate of the vertex. So this is going to be at 1, and then we have to find the y. To find the y, I just plug this back in up here. So this is going to be 1 plus 1 times 1 minus 3. So 2 times -2 would be -4. So the y part is -4. And now that we know that, my axis of symmetry would be where? X equals 1. So now, with all this information, I can graph it. So I'm going to put my axis of symmetry on here. I've got a vertex at 1, -4. Now, the really nice thing about intercept form is that now you don't need to do any more math. You don't have to do math to find the other points to graph your parabola. All we have to do is plot these x values of -1 and 3. And we now have a parabola. Okay, because the intercepts give you those other 2 points. So we're 1, 2 away on this side, and we're 1, 2 away on this side, so we can basically verify that we did the right thing with our intercepts by making sure that they're symmetric. That's basically what that allows us to do. Let's see, 16. And these will work the same way. Like if there was a negative out front, it would just make it flipped upside down. So I think it's going to change about it. So 16, I've got f of x is equal to 2 times x minus 5 times x minus 1. So where are my x-intercepts for this one?
X, 4, 10.
5 and 1? Yep. So 5 and 1. The 2 out front literally does nothing. It's just, well, it will do something in a minute, but not anything special. So then the vertex, to get the x-coordinate, we're going to add these two numbers together and divide by 2. So the x-coordinate of the vertex is going to be 3. Now, this is where the 2 is the only time the 2 is really going to be relevant. When I plug the 3 in for x and I multiply everything, that's the only time the 2 is relevant. So 2 times 3 minus 5 times 3 minus 1. So that's 2 times negative 2 is negative 4 times 2 is negative 8. So at 3, negative 8, I have a vertex. And an axis of symmetry at x equals 3. And so I have all of the information that I need to be able to graph this now. Alright, so axis of symmetry at 3. And then vertex at 3, negative 8. Then my intercepts are always still going to be up here. So I've got one at 1 and one at 5. So again, we're 2 away on both sides, so that's good. That means I did everything correctly. And just, oh, no, not that. Hopefully connect the dots a little better than I can today, apparently. All right, any questions about either of these forms? We're good. Okay. Next thing is write the quadratic function in standard form. So basically, FOIL. So 24, we've got y is equal to x plus 4 times x plus 3. So I'm quite sure you FOILed before, but we do the first, so x times x, which is x squared. Outside, so x times 3, so plus 3x. Then inside, so plus 4x. And last, 4 times 3 is 12. And then we just rewrite this as y is equal to x squared plus 7x plus 12. Now, what I will tell you is I often will, well, 1, I don't usually draw the little rainbow lines, okay? But 2, when there are not numbers in front of the x's, I oftentimes will just go, all right, that's x squared plus 4x plus 3x, and then just go ahead and write that as 7x on my paper instead of writing this intermediate step. If you need to write the intermediate step, totally fine, but if you're okay with skipping it, that's also okay. Because when we do the reverse, when we start with this, I will go straight from this step to this step without the intermediate step most of the time. So I'm sure in my mom's class, if you had her, Christian, I don't know what your teacher would have done, but you probably had to write this intermediate step is my guess, and I require that when I teach Algebra 1. But when we get to Algebra 2, I'm like, if you can see it and you can do it, just skip the step and write it. So totally up to you, but I just want to let you know that I am okay with that. 26. H of x is equal to 4 times x plus 1 times x minus 6. So basically, they're giving us problems in intercept form, and they just want them written in standard form. Is pretty much the only thing that we're doing. And so, hypothetically, other than the fact that I ask you for your intercepts, if you're like really struggling to graph an intercept form, but you're really good at standard form or something like that, you can actually convert your intercept form problems to standard form, and then you can just figure out what the intercepts are pretty much from that if you just say weren't really good at it for some reason. So when I do this, I would always do the stuff in parentheses first. Like I would FOIL those first and then multiply everything by 4. So this one will have like an intermediate step, but I usually do it like this. I'll do 4 and then I'll bracket it off. So I've got x squared. Then I've got minus 6x plus x. That would be minus 5x. And then 1 times negative 6 is negative 6. And so then at that point, I would multiply everything by 4 and get 4x squared minus 20x minus 24. Now, if you feel like you can multiply all that at once and only write one step, that's fine. But if you get the answer wrong, obviously, the less work you have in something like this, then, you know, I'm going to be like, well, how did they get from there to there if you, let's say you only multiplied one thing by 4 and not all of them or something. At least having this out front, I know that you need to multiply, and maybe you just did the math wrong. So, and that's not to say you can't multiply by 4 first, but I would just wait and do it at the end because it's easier. Questions about those?
So, the sign in the box.
Where?
The brackets. I don't know where you got the sign from. It's just for multiplication.
Yeah. So x times x was x squared. And then I had minus 6x plus x. From that, I just combined it into one step to get the minus 5x. And then 1 times negative 6 is negative 6. All right, one more of these just because it's written a little different. This is going to be written in Vertex form. So I just want to make sure that you know how to do one that's written in Vertex form to get it in standard form. So g of x is equal to negative, in parentheses, x plus 6 squared plus 10. So if you have this, now you might potentially remember special types from when you did the multiplication back in Algebra 1. But when you have x plus 6 squared, okay, that's a perfect square trinomial. And so if you remember the shortcut for it, you can just go straight there without having to rewrite it. But I'm going to rewrite it just for the sake of you seeing it. So this is really negative times x plus 6 times x plus 6 plus 10. Okay, so if you don't remember what a perfect square trinomial is supposed to multiply into, then you can rewrite it this way and then just do the process like we did on 24 and 26. So I've got negative out front of all of this, and then that's going to be x squared plus 6x plus 6x. So that's going to be plus 12x, and then 6 times 6 is 36. And then plus 10. So I've got this negative sign going on all of this stuff in the bracket, and then I'm adding the 10, so I'm going to do that in one step just to eliminate having to write so much. So negative x squared minus 12x. This is minus 36 plus 10, which is minus 26. So just saving having to write another step would give me that answer. Any questions? Ringing a bell a little bit, maybe. Okay. Then your problems 3, 5, 13, 21, 25, 27, and 31.